Hello again, year 8. Today we're going to build on the work that we did when we were multiplying fractions last lesson and look at how we can expand that to dividing fractions. So before we start talking about actually how we're going to divide fractions, we're just going to talk about equivalence for a minute. Now, in maths, there are lots of things that are equivalent. We've talked about equivalent fractions. We know there's equivalence between decimals, fractions, and percentages. We also know that some calculations are equivalent to each other. So, for example, you will have learned very early on when you did some maths in primary school that 3 plus 4 is actually equivalent to 4 plus 3. It doesn't matter the order that you do these calculations for addition. This is called commutative, when I can swap the numbers round and it not matter. Now that isn't true for subtraction. If I swap these things round for subtraction, 3 take away 4 is not the same as 4 take away 3. 3 take away 4 would be -1. 4 take away 3 bring 1. So those wouldn't be equivalent calculations. So why am I talking about this? Well, the reason why I'm talking about this is for every single division calculation, there is an equivalent multiplication. Let me explain with a very, very simple example, and there's no need to write any of this down, by the way. I know, for example, that when I find a half of 12, most of you would do that by doing 12 divided by 2. And 12 divided by 2 would be 6. But another way of thinking about that exact same question is a half times 12. If you had a half 12 times, you would have 12 halves, which is also 6. So two different approaches to doing the same question there. One where we've turned the question into a division, the other one where we've looked at it as an equivalent multiplication. And that is the exact approach we are going to take to dividing fractions today. We aren't going to actually physically do what we call a division. We are going to talk about an equivalent multiplication. So if you've managed to get a copy of my note sheet, that's great. If not, make sure you have the title and the objective down in your book today. So I've said to divide two fractions together, we are going to use an equivalent calculation. The equivalent calculation is to multiply by the reciprocal of the second fraction. Now, reciprocal might be a completely new word to you. It's going to come up more in GCSE. But basically what a reciprocal is if I have a fraction, a divided by b, the reciprocal of it is the numerator and the denominator switched around. So it'd be b divided by a. So in essence, what we are going to do today is we are going to leave our first number or fraction alone, and we are going to multiply by a reciprocal. So let's see how this works with some examples. So 6 divided by 3/8. Well, the first thing that I want you to think about is this 6 being 6 whole ones. So I'm just going to write it as a fraction. We saw that last lesson. I'm going to change my divide to a times by sign, and I'm going to do the reciprocal of 3/8. So I'm going to swap the numerator and the denominator around, and that is 8/3. Okay, as soon as we've done that, we are now doing last lesson's maths. We are multiplying our fractions together. So can it be cancelled? Yes, it can. Can divide both of those by 3 to get 2 and 1. Let's times my numerators together. That is 2 times 8, which is 16. And 1 times 1 is 1. So 16 over 1, which is 16. Now you might be wondering, well, why does this work, sir? I'm not going to explain it in a great length or detail. What I'm basically going to say is we know that division and multiplication are the inverses of each other. So by changing the divide to a multiply, we are in essence doing one inverse. And when we do a reciprocal, we are in essence doing a second inverse. And it's kind of those inverses that cancel each other out as to why the answer is equivalent. Let's look at a second example. So I've got 8/9 divided by 3, but again, we're going to think of that 3 whole ones as 3 over 1. So I leave my first fraction alone, and I am multiplying by the reciprocal. So I swap the 1 and the 3. So I am multiplying by a third. Is there any cancelling that can be done on this one? No, there isn't. Nothing that cancels a numerator with a denominator. So I can multiply straight away. 8 times 1 is 8, and 9 times 3 is 27. So the answer to that one is 8/27. 5/9 divided by 2/3. So leave the 5/9 alone. And we are going to be timesing by the reciprocal of 2/3, which is 3 over 2. Now this one, I can see some simplifying. 3 and 9, numerator and denominator, both in the 3 times table. So those can be divided by 3 before I multiply. 5 times 1 is 5, and 3 times 2 is 6. So the answer to that one is 5/6. 4/15 divided by 2/3. If you're feeling confident, you could pause the video here and have a go at this one independently, but I'm going to do it now. So 4/15 I leave alone, and I multiply by the reciprocal of 2/3, which is 3 over 2 again. 2 lots of cancelling that can be done here. I can divide 4 and 2, both by 2. And I can divide 3 and 15, both by 3, which is 1 and 5. Finishing that off, multiplying it together. My numerators multiply to make 2, and my denominators multiply to make 5, making the answer to this one 2/5. Now once again, this bit of maths works for mixed numbers. And just like we did last lesson, to do this, we just need to turn the mixed numbers into improper fractions first. Now this is where a few students think they've got a shortcut. They can do all of this in their head, mix numbers, turn it to improper fractions, do the reciprocal in their head, and this is where mistakes are made. So don't try and miss out any steps. Don't rush it. Take one step at a time. So I'm going to begin by writing both of these as improper fractions. 3.5 is 7 over 2. Notice that I'm leaving the divide there for the time being. 1 and 2/3 is 5/3. Now I'll worry about my equivalent calculation, which is 7 over 2 times 3/5. The reciprocal of 5/3 is 3/5. No cancelling to be done here. So this is 21 over 10, which is 2 and 1/10. Final example, 1/7/8 divided by 3 and 1/3. Again, let's do it in the same way. Don't do too much in one go. 1 7/8. That is 15/8. Divided by 3 1/3. Well, each whole one is 3/3, so that would be 9/3 plus the extra one, 10/3. Now let's find our equivalent calculation. We are going to multiply by the reciprocal of 10/3, which is 3/10. There is some simplifying that can be done on this one, 15 and 10, both in the 5 times table. So I can replace that with 3 and 2. And then multiply together, and I get 9/16. So there are some questions for you to try. So go back to my instructions, read those through, have a look at the questions on the PowerPoint. Once again, there are level 1, level 2, level 3 questions, and all of the answers are provided. So remember, the last 5 minutes, check the questions that you have done. Mark those questions, and then maybe take some photos ready for the end of the week. Of course, if there's any problems, you may ask questions in the Ask the Teacher channel.